So far we have worked on simple values like number, string, boolean. But in real world programs, data isn't always that simple. Imagine modeling a user profile. It would contain a username, an email address, age, or maybe a flag to track if the user is active or not. Yes, these values individually can be a number, string, or boolean, but together, any user profile is created will have the same structure. This process is same for any other implementation. Say for example a rectangle. It doesn't matter what is the size, a rectangle should always have two sides, height and width. Both are integers. So in these situations, we don't want to manage each piece of information separately with scattered variables. Instead, we need a way to group related data together under one name. Hello everyone, welcome to another video of the Learning Rust series. So you have already got the idea that we'll be learning struct in this video. By definition, a struct, or in short for structure, is a custom data type that lets us group multiple pieces of data into one logical unit. Think of it like a template, or as a container for fields, each with a name and a type. An example we have seen before is a user profile. We need to start with the keyword struct, followed by the name of the structure. Then within curly braces, we need to declare the fields for the user. We have a username of string type. Then email is also of string type. Age of a person is always a positive number. So an unsigned integer is more than enough. To check if it is an active user, we'll add another field of boolean type. Now this becomes the structure which we can use as many times we want in our program. Now if we want to use it in our code, in the main function we can create an instance of the user. Let user1 is a type of user. Here inside the curly braces we need to add the values for user1. First is the username. This is a string and let's use the name Bob. Here two things I have to mention. First, the name of the field should match exactly how it is declared in struct. And the second is the order of the field doesn't matter. So if we want, we can write age before email. We'll add email first here. It's a string bob@example.com. Finally, we'll make the active flag true to show Bob is active. Now we can use this user1 to get any details of Bob. Let's see by printing it. Println username is, here we have the age with email address is now active. Let's not forget to provide the variables. We need to use the dot notation to get the field. First is user1 dot username. Then we want to print the age. So user1 dot age. Then user1 dot email, and finally the active flag. This prints all the user details as per the print statement. User Bob is 25 years old with email bob@example.com is now true. This doesn't look good. We want it to print active or inactive instead of true or false. We can print active and inactive by using the control flow. So if user1 is active, return active, else return inactive. Now running it prints correctly. By default, the struct user1 is immutable. So if we change the age before printing, it will throw an error. It is standard in Rust. If you want anything to be mutable, you need to explicitly specify it. If we add mute keyword in the user1 declaration, it will print fine. Now, if we already have declared a specific field before instantiating the struct, we don't need to rewrite it again. We can directly use that variable while declaring. Let's say we already have a variable for username. So while creating user1, we can write username colon username. This works fine as well. There is also a shorthand available here. Since name of the variable, which is username, is exactly same as the field in this struct, we don't really need to mention this colon username. Just writing username would work fine. If we want to instantiate another user but based on an existing one, we can use the struct update syntax. This is especially useful for creating a new instance that's mostly the same as the old one, but with a few changes. Let's create user2 based on user1, but the age is different. Let's make age 30. Now to keep other values same as user1, all we need to write is dot dot user1. This syntax creates a new user2 with the age field set to a new value while the other fields are copied from user1. Now we add another print statement to print all the fields of user2, same as we did previously for user1. Running the program will print user1 and user2. See, the age in the second line is 30 as expected for user2. If you are not using the struct update, then it is mandatory to declare a value for every field present in the struct, or you can use option enum as well. I should mention one thing here. When we use this struct update syntax, it will move the heap allocated data types like strings. This means that once user2 is created, you cannot use user1.username or user1.email anymore. Since they are strings, the ownership is moved to user2. But you can still use user1.age and user1.active because they implement the copy trait. So their values are copied and user1 remains valid for those fields. This ownership transfer is not only for struct update, but also for sending a struct to another function. There also, the ownership of heap allocated data type moved to the new function. I'm not showing it here in this code, but this is something to remember while sending a struct to a function as a parameter. Better way is to send the reference of the struct if no mutation is required. We also have tuple struct. It is a variation of struct that are like tuples but have a name. They are useful when you want to give tuple a meaningful name but don't want any named field. For example, to denote RGB color, we need 3 integers. We don't need any name of the field because we know they are always specifically in that order. All we need is a tuple with 3 values. We write struct color and then define the tuple type. This is the syntax for the tuple struct. So if we want to instantiate for the color red, we can write let red equal to color. Red is 255, green and blue are 0. Let's also print it individually. For red, green and blue. To access the values, we can use the dot operator for tuple. So red dot 0 gives the red value, dot 1 for green and dot 2 for blue. Now running it shows the RGB values. There is another type of struct called the unit-like struct. These are struct but without any field. They are useful when you need to implement a trait on some type but don't need any data to be stored within it. Since we haven't learned traits yet, I'll park it for later. Just know the syntax. Simply struct followed by the name and ends with a semicolon. That's it. Now let's look at another example. Here we have a struct for rectangle with height and width fields. In the main function, we created rect1 with height 50 and width 30. Finally, printing the area by multiplying height and width. This code runs fine and prints the area. Here we are manually finding the area by multiplying the two sides manually. Now it would have been much useful if we had a method of the struct to calculate the area. A method is a function associated with a struct, and its parameter is always self, which represents the instance of the struct the method is being called on. What it means is that we could have found the area just by writing the method rect1.area, and it would have returned us the area of the rectangle instead of us manually calculating it. This can be performed by having an implementation of the rectangle struct type. To achieve this, we write impl followed by the name of the struct. Inside the curly braces, we create the methods. The method we want to create here is to find the area. So we write fn area and pass reference to the struct on which the method is being called. So for rect1.area, this self would refer to the rect1 rectangle struct. We don't really need to take the ownership here, so we are just taking the reference. We'll be returning area, so let's just have the same data type as the return type. To return the area, we'll just multiply height and width of self. We want it to be an expression, so no semicolon. Running this program will print the same result. In addition to methods, we can also define associated functions within the impl block. These functions are associated with the struct but do not take self as the parameter. For example, to create a new rectangle, every time we need to write this whole block, which for larger struct can be tedious. To simplify this, we can create constructor using associated function. We write fn new. This function don't take self as a parameter because this will not get called on a specific rectangle but on the struct itself. It means that we can't use rect1.new. Logically also, it doesn't make any sense to create a new rectangle on an already created rectangle. So here we take the sides as the parameters. Height as u32 and width also as u32. This function will return a rectangle type. Will return a rectangle with parameter height as the value for the field height and parameter width as the value of width. Now to create a new rectangle in the main function, all we need is to write let rect2 equals rectangle colon new, then pass two values as height and width. Can you recognize this syntax? We use this to create a new string from, then the string literal. This is a prime example for associated function of string type. In our example, new is the associated function of the rectangle type. Now we have a new rectangle. All we need is to print the area. Print ln area of the second rectangle is rect2.area. Let's run the program. You can see the area of the second rectangle also printed correctly. We also have traits, generics and lifetime in Struct, but since we have not covered those, I'll not discuss those in this video. So you can see Struct help us organize related data instead of juggling separate variables. It makes the code more readable, maintainable, and also help preventing mistakes. If you have heard about object-oriented programming, I should mention that Rust is not an object-oriented programming language, but it borrows some useful ideas. So yes, structs can act somewhat like classes, but without inheritance. Instead, Rust encourages composition and traits to share behavior. That's all about Struct for now. Hope you're enjoying this series. Don't forget to share your thoughts in the comment and subscribe so that you won't miss the next one. Goodbye for now.